Hi, this is Open Up Resources, Algebra 1, Unit 7, Lesson 12, Formula for Success. So are the notes for it. So we are going to start by solving this equation, completing the square, and using inverse operations. So I need to see what I should do to complete the square. So let's start with divide by 3 for these guys so that we have 3 parentheses, x squared minus 6, 2x minus 4. So then I need to divide this one by 2. So then I have 3 parentheses x minus 1 squared. And then to get my last one here, 1 squared is 1, so I have negative 4. 1 squared times 3 minus 3 would be negative 7, so it's minus 7, and that equals 0. So I'm actually going to erase this part because I need that out of the way. I'll put that up here. So I had negative 4 minus 3 equals negative 7. Okay, so from here, I need to plus 7 to both sides so that I end up with 3x minus 1 squared equals 7. Then I need to divide by 3. So then I have x minus 1 squared equals 7 thirds. And then I need the root to undo those. So hopefully this is all old hat. We've been doing this. X minus 1 equals square root. Oh, I'm running out of space. Let's move it up. So go up here. X minus 1 equals plus or minus the square root of 7 thirds, which means I need to add 1 to both sides. So x equals 1 plus or minus the square root of 7 thirds. Okay, so I've solved that. And just kind of review what we had last time. Line of symmetry would be this part right here. That's my x coordinate, so x equals 1. And then my distance from that line of symmetry is that square root of 7 thirds. Okay, so that's what we kind of ended up with last time. So let's move forward now. Now we're going to solve for the formula. We are going to create the formula that helps us out. So solving the equation by completing the square seems like it goes exactly the same way every time. So if we were to generalize the process and make the ax squared the standard form, ax squared plus bx plus c, to equal 0 so that we can solve for those x-intercepts, let's think about what our diagram has. So here's this picture, and we're going to fill in these gaps. So how many big blocks do I have? Well, I have A, and in this case, it's only 1, right? So imagine one of the big blocks and then the extra smaller blocks. We goes into each section. You've been given the start below. So when we have ax squared plus bx plus c equals 0. So when we do this, first we have to divide everything by a, right? And then before we can put a in the front, we then have to divide b over a divided by 2 again, which is the same thing as multiplying by a half. So that means I have x plus b over a times 2 is 2a squared, right? So that means this one is b over 2a, and so is this one. I'm going to turn this sideways here. B over 2a. So then if I do my little multiplication piece, x times b over 2a is b over 2a x. And then this one would be b over 2a x. And so when I have my fourth one, right, 1 down here, I'm taking b over 2a times b over 2a, which would be b squared, b times b. 2 times 2 is 4. A times a is a squared. So that makes this guy over here. Well, what I do with that is I actually have to take that from c after I've multiplied by the a. So I need to take c minus, let me use a different color over here. Come on. So I'm going to use a different color because to find my number that goes over here, I have to take c minus this here. But I have to multiply it by a first, right? I square this, but then I have to multiply it by the a. So a parentheses b squared over 4a squared. Okay, so that's kind of what's left over here. So if I go down here, hopefully you followed that. Now that we've filled in all these, what expression do you need to subtract from c? We basically did it right there. Don't forget you have a blocks in the diagram, so make sure we solve that out. So when I'm doing this, I am basically, I'm doing c minus a parentheses b squared over 4a squared. Like that. So that I can see kind of what I've got there. So what is the equivalent expression in vertex form? So if I'm going to take this, I actually need to, in this case, we don't have the a because we already had the a in there. So we are actually going to take out this one for the moment. So if I were to actually subtract this, what I'd have to do is no, never mind. I was right. So when I put the a in here, so if I multiply this by a, then it's basically a times b squared, but the a and the squared cancel out. So I'm really just taking c minus b squared over 4a. But to be able to subtract these, I have to have the same denominator. So if I put 4a over 4a, that equals 1, right? Anything divided by itself is 1. Now I have 4ac minus b squared, and I can have it all over the this as well. So that's kind of what I'm working towards here. 4ac minus b squared all over 4a. So what is the equivalent expression in vertex form? So if I put this in vertex form, I have f of x equals, and I basically have it up here as my first part, right? A x plus b over 2a squared. And then I'm adding, I don't know why I put that there. Then I'm adding c, but c is really c minus that b squared over 4a. Nope, 4a. See if I can squeeze it in there. Need this to be the size of my screen. C minus b squared over 4a. Okay, so, and then to make it even clearer, I need to have f of x equals a x plus b over 2a squared plus, then we're going to put this part right up here, 4ac minus b squared over 4a. All right, so what my line of symmetry is. So looking at my line of symmetry, there's my x value, right? Because I take away my x value. So line of symmetry would be x equals negative b over 2a. And then my vertex would be my x and my y. So it looks kind of ugly, but my x is negative b over 2a, comma, then all of this is going to be my y, 4ac minus b squared over 4a. So that's my vertex. All right, so now we are going to solve these using inverse operations and some fancy algebra. So looking at what we've just done, we are going to solve this for x. X equals whatever. So it's going to make it equal to 0. And it's kind of complicated, but at the same time, you're just doing basic algebra. All right, so I just don't know how much room I'm going to have on here. I'm going to need a lot of space. Okay, so I'm going to start with A. I'm going to go clear over here. A parentheses x plus b over 2a squared plus 4ac. You know what? Actually, I'm going to skip this step because that's going to be a lot of stuff here. I'm going to start by subtracting this on both sides. So I'm going to go ahead and put on here, after I've subtracted it, it's going to equal a negative, so notice it's a negative in front, 4ac minus b squared over 4a. Okay, so that's after I've made this over here equal 0. I'm going to subtract this from both sides, so I'm going to put the negative in front, so it's a negative 4ac minus b squared over 4a. All right, so once I do this, I have to divide by my a. Divide by a. So times 1 over a. And so how I'm going to work this one out is I'm actually going to distribute my negative to everything so that I can get rid of these parentheses and do my multiplication. So what I'm left with, I'm going to switch to purple because this is getting hard to read. So now over here, I've got x plus b over 2a squared equals, I have negative 4ac plus b squared over, now 4 times a is 4a squared. Okay, so now that I've got all that, I need to do my square root, right? To undo all of this, undo the squared. So undo the squared with square roots. And so I can basically take the square root of the top and the square root of the bottom. So we're going to split it in that way over here. So I have x plus b over 2a equals, so the square root, I can't really do the square root of, and I'm going to switch these because b squared is positive, and I'm going to subtract the 4ac, so I don't have that negative in front, over, now the square root of 4 is 2, the square root of a squared is a. So I'm able to simplify that. Now I need to subtract b over 2a from both sides, so those cancel, and this is a plus or minus, right? So now what I have is x equals, I'm going to put this in the front because that's what we've been doing, negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And now I've come up with my quadratic formula. And I could put it under one denominator. So I could write it, I'm going to go ahead and do this over here, or x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, because it's the same denominator, so I can combine them. So either one of these counts as your quadratic formula. And that's the proof. That's why it works every time. So let's go ahead and fill this in for this number here. I don't even know if I have room for it down there. Let me give myself some space here. So a is, we only have one x squared. B is, remember it's our standard form because we're going back to our, where is it? Right here. A is how many x squareds, B is how many x's, C is what our constant is. So I have 5 x's and I have 1 c, one constant. So now when I plug it into this, I'm actually, we'll go ahead and do, we'll do this first one, b over 2a. So I'm going to write it out as negative 5 over 2 times a is 2, because a is 1, plus or minus square root b squared, 5 squared, minus 4 times 1 times c is 1, all over 2 times 1, which is, I'll just still do this, I guess. I'll show all my parts here. All right, so now for the next one, I'm going to simplify pretty quick because we don't get a whole lot of space for this. So I have negative 5 halves. I should probably try to fit this all in one spot here. So negative 5 halves plus or minus the square root. 5 squared is 25. 4 times 1 is minus 4 all over 2, which I can then simplify to negative 5 halves plus or minus the square root of 21 over 2. And I can leave it like this. I can leave it as this equals x. Doesn't really help me when I'm actually trying to graph or solve something. So the square root of 21 is actually, divided by 2 is 2.3. I think this whole thing, figure out the whole thing equals this part. So then negative, that'd be a negative 2.5 plus 2.3 equals a negative 0.2. Right? Because that was a negative 5, negative b over 2. Yeah. So negative 2.5 is a 0.2 negative. Or I have negative 2.5 minus 2.3, and I get a negative 4.8. So those are my two possibilities that I have as my answers for that. Okay, so let's do the next ones. I wish they gave us a little more space on here, but we'll do our best. Okay, this next one I'm going to do in blue, so we have different colors. So A equals 1, B equals negative 5, C equals negative 5. So I'm going to just put a little line on here so I can make sure and have room for all this. So negative b, a negative negative 5 is a positive 5 over 2 times 1 is 2 plus or minus the square root of negative 5 squared is 25 minus 4 times 1 times negative 5 all over 2 times 1 is 2. Okay, so I have, again, 5 halves plus or minus. 4 times 5 is 20. Negative times a negative is a positive. So I have 25 plus 20. It's the square root of 45 over 2. And so we actually do not know the square root of 45. So square root of 45 is about 6.7. And so if I take 5 plus 6.7 divided by 2, I'm going to get, so 2.5 plus, and I'm going to run out of the space over here. So I'm basically going to do the 2.5 plus half of 6.7 would be, let me think, 3.3 basically. So 2.5 plus 3.3 would be 5.8. Or I'm going to do 2.5 minus 3.3 and get a negative 0.8, 0.9, 0.8, negative 0.8. So these are my two answers here. All right, next one. We're going to draw our line, do it a few shortcuts that I normally wouldn't do because I just don't have much space on here. Okay, so A equals 1, B is negative 6, C is negative 3. Okay, so now let's do negative B. So a negative 6 is positive 6 over 2 times 1 is 2, plus or minus the square root of negative 6 squared is 36 minus 4 times 1 times negative 3 all over 2 times 1. So I can actually simplify this. 6 divided by 2 is 3, plus or minus. 4 times 3 is 12, so minus a negative is plus 12. 36 plus 12 is the square root of 48 over 2. We still have the 2 there. Now, one thing we can do here is simplify our radicals as well. So 4 goes into 16. 16 goes into 48. So I could do the square root of 16 times the square root of 3, and I get 4 square root of 3. So 3 plus or minus 4 square root of 3 over 2. Well, 4 divided by 2 is 2. So 3 plus or minus the square root. Just a minute, I'm running out of space. Golly. Okay, so this turns into 3 plus or minus 2 square root of 3, which, again, when you go about doing this, we end up with plugging that into our calculators. 3 plus 2 times the square root of 3, we get x equals, adding, we get 6.5. And then when we take 3 minus 2 times the square root of 3, we end up getting a negative 0.5. There we go. All right, last one. Practicing using this. We'll go back to green. So A equals 2 this time. B equals 8. C equals 5. So negative B, so negative 8 divided by 2 times 2, which is 4, plus or minus square root of B squared, so 64 minus 4 times 2 times 5, all over 2 times 2, which is 4. Okay, so I have negative 2 plus or minus So there's a perk to having that separated. You might be able to simplify one of the things. Plus or minus. So 64, 4 times 2 is 8, times 5 is 40. 64 minus 40 is 24. Square root of 24 over 4. Now again, if I do my square root of 24 is the square root of 4 times the square root of 6. So then I can do equals negative 2 plus or minus 2 square root of 6 over 4, which these two would cancel, making it negative 2 plus or minus square root of 6 over 2. And when I actually type that into the calculator, I get x equals negative 0.8 and negative 3.2. All right. So now that we've used the quadratic formula, here's some questions for us. Answer a couple of these. Why do the solutions contain a plus or minus? Well, we have two roots, one on each side of the vertex, right? Okay, is it possible to have only one solution to a quadratic equation? What do you think? What'd that mean about the function? Well, if there's only one root, so if you actually could take that and it came up as one number, like 0, plus or minus 0, then yes, the vertex is on the x-axis. That just means that's where the point is. It's the only one. So what does it mean if the number is inside the root turns out to be negative? So this is kind of an interesting one. If there's, can't take a negative, nothing times itself equals a negative. So that means there are no x-intercepts. And spoiler alert, which means it's above or below the x-axis. And the spoiler alert is these are imaginary numbers that you will get into later in high school. So that's where imaginary numbers come in. All right, we will not worry about the ready for more today. Quadratic formula, we just did. So let's write it one more time. It is negative b over 2a x equals plus or minus the square root of b squared minus 4ac all over 2a. There you have it. We have proven it. Now we can use it, and it's all good. Thanks for joining us. We'll see you next time.